again, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to all of you guys. So I hope that all of you in a very good condition for today's class, and then for this, it's already 58 days that we facing this PKP. So I hope that all of you in a very good condition, okay? To all of you that going back to your hometown, so please do take care of yourself, okay? Because we just heard a news, okay, a student from any IPT, I'm not sure, so is already infected by this COVID-19. Okay, so please do take care of yourself and your family. Okay, so for today's class, okay, we're going to go through on the reinforced concrete column design. So I will go through on the two parts. The first one is on the introduction, and then the second one on the column classification, so and the example. So I will go through a bit faster, okay, so that we will not take a long time because it will take a lot of data to be used. Okay, I will share my screen first. Okay. Okay, all of you can see my screen, eh? Boleh nampak?
Boleh, sir.
Boleh sir, boleh.
Okay. Okay. So here is the reinforced concrete column design introduction. Okay, it downloading. So give a few minutes. So as usual, if you have any problem and you would like to ask, just turn on your microphone and ask the question. Okay, so at the end of this lesson, you should know how to define the reinforced concrete column. So we have a few types of the reinforced concrete column that we're going to learn and to design. And then differentiate types of the reinforced concrete column. We have a short column, we have a slender column. It's based on the height of the column. Okay, and then we have a two type, which is the uniaxial and also biaxial column. So we will have a look what is uniaxial column, what is a biaxial column. Okay, so on the introduction of the column are the structural members in building carrying roof and floor loads to the foundation, also known as the compression members. So we know that a column is the main elements, okay, become a bond or a bone, tulang to the building that will receive all those load from the slab, from the roof, okay, from the beam. Okay, so you have to know that column is normally will support the beam. Okay, column may also carry axial load as well as moment due to the continuity of the frame structure. So in a column, okay, so sometimes, okay, we will do a frame analysis. Okay, so in your next semester or next year, you will have a integrated design project class. So in your integrated design project class, so you will go through on the frame analysis in order for you to analyze the load on the column. Okay, because the load on the column is not given in the question, so you have to determine by your own self. Okay, column section is generally square or rectangular or circular. So normally for the building, or if it is attached to the building, normally we will have a square or rectangular. So as I do, as for your information, so for your column size normally will follow the beam size, especially its B, okay, its width, so that it will not the features or the architectural figures, okay, will not have any macam terkeluar daripada that beam. Okay, so it will not look nice. So it's become a very difficult for us to like to arrange for the perabot, furniture and so on. Sometimes if we would like to add another features, so if our column is terkeluar macam tu, it's quite difficult for us to add a few features. So when you would like to do your preliminary sizing of your column, you may refer to your beam first. So what is the size of the beam, so that it will properly sitting well with the beam. Okay, so with additional of the brick wall and so on. Okay, so dimension of a column and the position of the reinforcement is based on the requirement of the durability and fire resistance. So it is normal. We have to do the preliminary sizing based on the span over depth ratio and also based on the fire resistance. So this is normally that we use to determine the size of the column. Okay, wait for a moment. Okay, next is the still on the definition. Okay, class 9.5.1 of Eurocode 2 define a column as compression member, which its greater cross-sectional dimension is not greater than 4 times the smaller dimension. So means that your H maximum, okay, this is means that the dimension lah, okay. So your H should be less than 4H minimum, okay. H maximum, contohnya if for example our H minimum is 200, okay, time 4 is 800. So our H maximum should be less than 800, okay. It can be 700, 750, okay. The dimension normally we use is in contohnya for if we start the dimension is 200, when we would like to increase the size is 225, 250, okay, 275, so the increment of the column dimension. Okay, so this is two types of the column category, which is the braced column or unbraced column. So brace is the element that going to tight up the column in order to strengthen or to reduce, okay, the stiffness of the column. Okay, so ataupun senang cerita dia mengikat that column in order to macam kita pakai braces lah. Okay, so dia punya function adalah sama. So normally we will use a brace column lah. Okay, so lateral loads and stability are resisted by shear wall or other form of bracing capable of transmitting all horizontal loading on the foundation. Okay, here is the example for the braced column. So for the unbraced column, so lateral load and stability are resisted beams and slab. Okay, so normally this is the unbraced column where we can see here there is no element that going to hold the frame. Okay, so next thing is, sorry. Okay, the difference between the types of the column, another thing is a long column and a short column. Or long column we call as a slender column and also short column. Okay, on the long column, the column whose lateral dimension is a very small when compared to its length or height is called as a long column. So we will check the column classification. So based on this column classification, we will know either the column is a short column or slender column. It is generally fails by buckling. So buckling is okay, saya tak ada pembaris pula. Okay, this is for example if I do have a column like this, okay, this is a buckling. Okay, this is a buckling. So means that this is a failure of the long column, which is a buckling. So kalau dia short column, it's generally fail by crushing. Maksudnya macam the compression, they will crush. So the two part of the column will have a buckle. Okay, so dia akan membesar dekat tepi tu. So dia akan crush, that we call as a compression failure ataupun crushing failure. So ratio of the effective length to least lateral dimension is greater than 12, but for the short column is less than 12. So slenderness ratio is greater than 45, or slenderness ratio is less than 45. So that is the normal slenderness ratio that we use for the long column or short column. But we will determine the slenderness ratio, so based on the Eurocode method. So I will show the example later. So another thing is about the radius of gyration, how the load is carrying, and either it is much more bigger or lesser, and then the load of the long column is subject to the buckling stress, but the short column is subjected to the compressive stress because it fell due to the crushing. Okay. Okay, this is the behavior of the column. So failure of the column, okay. So ini adalah of the short column. So it due to the crush, biasanya dia akan berlaku shear, okay. And then dia compress, dia akan terbelah dua. Okay, and then for the buckling, they will have a slender buckling here, okay, because the load is come from here, so it's not fail like this, okay. It fail due to the buckling performance. Okay, another thing is displacement behavior for the long column. So it will have a less horizontal forces, but for the short column will have more horizontal forces. Okay, so this is how it behaves. Okay, this is the column dimension and notification that you have to know. Okay, so for the column dimension, okay, so for the column axis, for the major axis we call as a x-axis. Normally it will represent by h. Okay, dia punya dimension b times h. So for the minor axis, it is a z-axis, is represented by b. And then for the column height and the column clear height. So if I would like to enlarge a bit on this figure. Okay, this is the clear height, this is the actual height. So actual height is actually from center to the center of the upper floor to the lower floor. So the clear height is actually minus, okay, with the height of the beam. So we will have a look in the column classification how we're going to calculate the clear height. Okay, next is a column bending classification. So we have two types, which is due to the uniaxial column and also biaxial column. What is uniaxial column? So means that the column is connected to the beam at only one direction, either x direction or z direction. Where the biaxial column is the column that is connected with two direction of the beam, which is from x direction and z direction. Either it's one beam or two beam, for example. Okay, if we have only one connection here, okay, and then one direction here, we call as a uniaxial, although there is no beam at this side. So if we have another direction, we have this direction and also this direction, only one beam here and on one beam here, but it is two direction, we call it as a biaxial column. Okay, this is how we calculate the effective length for the isolated column. So it is shown in your Eurocode. So for a general definition of the effective length, so example of the effective length for isolated member with constant cross section are given in this figure. So different types of connection will give a different type of the effective length. So for example, here is a pin is equal to L0 is equal to L. Okay, so if it is a fixed and also free end here is 2L. Okay, so because the slenderness will be increased. Okay, so if it is a fixed here and also pin here, 0.7L. Okay, it's a fixed is L over 2. Okay, so and another things lah. Okay. Okay, now is on the design specification. As we know, so before we start our design, we have to know the design specification, all those parameters that we need to know about the element that we're going to design. So some of the information is repetitive. So from the previous lecture, from the slab and also from the beam. So I will repeat it again, but there is a some of the parameter is a different. So you have to be careful here. Okay. So the first one is on the design specification. So for the characteristic strength of concrete is same. So normally the characteristic strength of the concrete we start from 30 MPa, but there is some consultant would like to use a 35 MPa. So it's depend on the company, depend on the client that how about the performance, the needs of the performance of the building. So sometimes for the high end, they will use a higher grade of the concrete. Okay, so 35 and above. Okay, so the characteristic strength of steel, as usual, we use a 500, but it's allowed to use 460. So because in Malaysia, 500 is still not available, so therefore we use 460. So you have to be careful. So if in your exam the grade is given is 460, so you have to use 460. Read the question carefully. Don't simply, okay, don't simply, so you take the value 500 without read the question carefully. Okay. Okay, so for the column dimension here, I would like to explain to you again. So for the column dimension, so due to the fire resistance, we have to follow the simply supported beam, okay, not continuous. So for example, if your R is 120, which is 2 hours, so your B minimum is equal to 200 lah, okay. So it depends on how you would like to have your column dimension. Okay, for the span over depth is using this formula. Okay, so here is some of the shape, okay, that we can have for the beam, for the column. Okay, so you may have an additional information from this website. Okay, so I will try to enlarge here. Okay. So this is okay, this is the normal, okay, size of the column, okay. So for example here is 35 times 25 ni centimeter So 350 times 250. Okay. So the arrangement of the reinforcement is like this. Okay. So I will the reinforcement, okay, the minimum numbers, okay. Nanti saya akan explain the minimum numbers of the reinforcement dalam on steel reinforcement. So you can have like this also, okay. So this is a different size of the column. So if we have a look here, so you have you can have your B here is a very small. Kenapa your B here is a very small compared to your H here? Okay, because they would like to incorporate with the beam size so that the column is together with the beam. So it will not more than the beam size lah. Okay, so this is how we have determined the column shapes. Okay, so if it is a round, it should be like this. Okay, column can be in irregular shape like this. Okay, so it's depend. So but the design method is a different lah. Okay, so we will not going through on this in our lecture. Okay, so next on the design life as usual, so either 80 to 50 years or 100 years is depend on our types of building that we're going to design. So on the diameter bar, okay, here I would like to explain more on the diameter bar here. Okay, so you have to be careful on the diameter bar of the column. So it's a bit different, okay, from your beam and also for your slab. The longitudinal bar should have a diameter of not less than the diameter minimum. So normally our diameter minimum is 8 mm, but it's advisable for you to apply 12 mm and above. Okay, so the total amount of the longitudinal reinforcement should not less than AS minimum lah. As usual, we have to check your AS minimum and also AS maximum in the design. So the formula for AS minimum is different from slab and also from beam. So the formula is here. Maximum, we have to compare between these two value, 0.1 NED. NED is the axial load given, okay, in the question, or you have to determine your own axial load based on the frame analysis that I do already explain before. So, but in your subject here for the CES522, normally NED will be given. You will not have a frame analysis by your own. Okay. So, and then FYD. So FYD is same as what we have learned before lah. Okay, the design yield strength of the reinforcement. So for the AS maximum is equal to 0.04 AC is same. Okay, AC is equal to B times H. Okay, so this is how we determine the longitudinal reinforcement for the column. So in terms of numbers of the reinforcement, you have to take note on this. The numbers of the reinforcement for column, okay, if it is a square or rectangular column, the minimum numbers is 4. Okay, for one at each corner. Okay, normally if it is a square column, we will have 4. So if it's a rectangular, we can have more. Okay, because the rectangular will have two different dimension, right? So better for you to have more, so that at the long dimension, for example, for the x-axis, which is at the H, okay, normally the size is much more bigger than your B. So maybe in between, you need another reinforcement. So it depends on how you arrange your own reinforcement, how you decide the numbers of your reinforcement. Okay, for the rectangular, normally it is a odd number. Okay, the minimum numbers is a 5. Okay, cannot be 3. So it's quite weird if we have 3. Okay, so the spacing should be equal lah. Okay. Okay, next is that the exposure class is same as what we have learned before. Okay, in the previous topics, the nominal cover is the same. We use simply supported here, and then another thing is same what we have learned before. So you have to make sure that, okay, the class of the concrete, either it is a 30 and above or not, you have to reduce the class here by 1 or not from, for example, XC2 to XC1 and so on. Sorry. From the structure class S4 to S3 and so on. Okay, you have to recheck it first. Okay, so axial load. Okay, so this is an example how we determine the axial load. So I will give you just an example for you to explore, not for you to really calculate it. So how do I get this axial load from the frame analysis? So this is the same example that I share with IDP student. Okay, so for example, I would like to design this column A5. So how do I get this NED? So the NED, we will analyze each of the beam that is connected for both direction, X and also Z direction. So we have to calculate the load on top of this beam and also on top of this beam. Then we will transfer the load from this beam to this column. So for example, we have 3 floor column, 1, 2, 3. For each floor, they will have their own NED here. Okay, so means that we will have 3 NED. Therefore, we will design the column one by one. This floor, this floor, this floor. So it means that on the column classification, we have to check one by one for this floor, and this floor. That is possible if, for example, this column is quite high. Okay, for example, the length is 4 meters. There is possibility this column will be slender, this column will be short, this column will be short. Okay, so that's why we have to calculate it by one. Okay, so this is for the Z direction. Then I'll get the moment and also the axial force for the roof floor, 43.83. For the first floor, 168.04 kilonewton. And then for the ground floor, is 278.28 kilonewton. Okay, and then this is the common failure of the column. Before that, have any question or not, class? Before I continue? May I continue?
Yes, sir.
Okay, so next I will continue on a common reinforced concrete column failure. Okay, so there is a three types of column failure here that is normally or commonly happen. Okay, so the first one is compression failure, like this one. Okay, this one is the buckling, and then this is combination of the buckling and also compression. Okay, so that's it. Okay, as for before we continue on the column classification, so just some motivation word. Anyone who has never made a mistake has never tried anything new. Okay, new. Okay, learn from yesterday, live for today, hope for tomorrow. Okay. Okay. So I will continue on the column classification. Okay. So the column classification, okay, for the Eurocode and British standard is different. Okay, this is specifically for Eurocode. Okay, so for Eurocode is a bit longer than the British standard. So if you work in the future as a structure engineer or structure designer, your company using British standard, so you have to follow that method. So it is a different method lah. Okay, so at the end of this lesson, you should determine the slenderness of the column, okay? And then differentiate the classification of the column, either it is short or slender column. So, column classification is a procedure in reinforced concrete column design to classify the column is short column or slender column. Second one, determination of the column classification is important to determine the procedure to design reinforced concrete column, because the procedure to design the short column and slender column is different. Okay, same as what we have learned in beam and also in slab. So different types of column, different types of beam, different types of slab have different types of procedure to be adopted to design the element. Column classification mistake will cause the reinforced concrete design absolutely wrong. Okay, absolutely wrong. Okay, bukan there is a justification or mitigation plan also on. It's totally wrong and affected the overall structural performance of the building, because this is the main element that will support the building, that will, if the main, okay, the main backbone of the building is failed, absolutely the building can easily to be failed, okay, to be collapsed. So it's overall structural performance of the building, because column is the frame structure that will transfer the load or receive the load from the total action from roof, slab and also beam to the foundation. Okay, here are the column classification procedure. Okay, so we will go through one by one. Okay, the first one, okay, is the dimension and size. So for the dimension and size, so we have to know the dimension of the column, B times H. So LZ is the clear height, okay, the clear height. So the clear height is equal to height of the column minus with height of the main beam. Okay, main beam maksudnya at your main direction. Okay, your main direction. Okay, and then for the LY, okay, is at your secondary direction. So secondary beam punya size. So for the main beam, if we have both sides connected, okay, so we have a left and right. So we have a main beam 1 and also main beam 2. Normally, main beam 1 is at our left, main beam 2 at our right side. Okay, for the secondary beam, oh sorry, this is actually for, this is a secondary beam. Okay, this is not a main beam, this is secondary beam. I will do some correction and then I will update again in the slide. Okay, So for the secondary beam, normally if we turn the plan, okay, we turn the plan, so it's become the left side will be your secondary beam 1, the right side is secondary beam 2. Okay, next is the moment of the inertia. So the moment of inertia, you have to be careful, especially for the column. Okay, so for the main direction, ia adalah BH cube over 12. For the Y direction minor axis is B cube H over 12. Okay, for the beam, dia punya moment of inertia is as usual BH cube over 12 for both. Okay, for the column stiffness, okay, is equal to K is equal to EI over L. So for the column, IZZ from here, so over LZ. For Y, IYY over LY from here. Okay, so just ignore the E value. Okay, just ignore the E value. So on the example, I will explain later. So and then for the main beam and also for the secondary beam, you have to repeat the same process again. Okay, next is the relative column stiffness K. Okay, equal to K of the column divided by 2 times the summation of K beam. So we have to calculate both for the Z axis and also Y axis. Okay, so K1 and also K2 normally at the top end also bottom end will have the same value. So you have to be careful for the Z axis, it should be bigger than 0.1. Okay, it's not equal, but it should be bigger. Okay, so if it is lesser, you have to use 0.1. Okay, so y-axis should be less than 0.1. Okay, so this is the formula. How you going to calculate your relative column stiffness? Okay, next is the effective length of the column. So normally for the effective length of the column, it's stated in the question either the column is braced or unbraced. So if it's not stated, normally we will use a braced column unless it clearly unbraced column. Okay, if it is a clearly unbraced column. So this is the formula to determine the effective length of the column. So this formula is in your design appendix, so no need to worry. Another thing is because of your test will be open book, so you will have your own reference how much that you would like to have. Okay, so I hope that you can answer this question very well. Okay, because it is open book. Okay, so this is the formula to calculate the brace column, and then for the unbraced, you have to compare between these two values, and then you will get the maximum. And then the radius of gyration. So IZZ is from the previous value. AC is actually the Is there any problem? Is there any problem, class?
No, sir.
Okay. So if because I do receive a message from your friend, they said that they hold. Also, it's your own problem. Okay, so if anybody that have a problem with the connection, I hope that you can get back in, and then wait, I'll check first. So some of you facing ada kena hold on . So you click hold on tu. Okay, nanti dia akan unhold. So dia akan okay. Okay, I'll back here. Okay, next process is the radius of gyration. So for the radius of gyration, okay, so this is the formula. So you have to recheck it, okay. Either, especially for okay, why you should know this condition, okay. So I will enlarge here. Okay, kenapa? Penting sangat kamu kena tahu this one. Okay, jangan confuse. Please don't be confused. Okay, so especially, okay, if it is biaxial, kita takkan ada masalah. So normally, kalau it is a uniaxial, so the moment will acting only at one direction only. Okay, one direction. Either it is at minor axis or major axis. So you should know which value that you have to use here. Okay, so by referring to this figure, you should know how to use these section properties in order for you to calculate your radius of gyration. Okay, so if you don't have you have any problem, you get back to me. Okay, so next one is the slenderness ratio. So from the LOZ over IZ from here, IY from here, and then last one, we have to calculate the slenderness limit. So the slenderness limit is equal to 20 times A times B times C over square root n. So this formula is in your appendix, where A is equal to 0.7, where B is equal to 1.1, and your C is equal to 1.7 minus Rm. So Rm is equal to ratio of moment MO1 over MO2. MO1 is a bottom moment, MO2 is a top moment. So when you would like to calculate your C here, okay, 1.7 minus Rm. So if you get the answer for your ratio of moment here negative, so you have to include the negative value. So if you get a positive, you have to include the positive value. So your N is equal to NED over AC FCD. FCD is equal to 0.85 RCK over lambda gamma C. So the gamma C is the gamma C is equal to 1.5. Okay, and then you have to determine the lambda limit, slenderness limit, okay, for both axis Z and also Y. So means that your C, you will have two, CZ and also CY, okay, because your ratio of moment will have a 2. Ratio of moment for Z and also ratio for moment for Y. Okay, last but not least, so after you determine the lambda limit and also you determine the lambda Z and also lambda Y, okay, you have to compare the result. Okay, so if it is lambda Z and also lambda Y, both condition is less than the limitation value, so therefore it is a short column. So if you get both is more than the limitation value, or either one, for example, you get here lambda Z is more than lambda limit Z, lambda Y is less than lambda limit Y. So means that one is more, one is less. So it's considered as a slenderness column. So if both of it is more, and then it's considered as a slender column. Okay, then I will continue on our column classification example. Okay, on the column classification example, here are the example. Okay, so how to determine the column classification? For example, we have the height of the column here is 5. Okay, and then we have the main beam here. So here we'll consider as a main beam 1. Here is considered as a main beam 2. Have a the size of the beam is same, but the length is different. The length for the beam 1 is 6,000. The length of the main beam 2 is 8,000. And then we have a secondary beam here, okay, which is the size is 250 times 400, and then the length for secondary beam 1 is 4,000. For the length for the secondary beam 2 is 4,000. So the secondary beam have the same length. So here given the FCK and also FYK, and then we know that this column is a biaxial column because it is connected with two beam at 2 direction. Okay, and then here are the given moment has been analyzed before. So here are the value of the moment. Here is MO1, here is your MO2, here is your axial load NED. Okay, the first step here, okay, is the dimension and size. So first one is the column dimension and size. B times H is equal to 275 times 350. Okay, it is given here 275 and 350. 275 is become your minor axis. Here become your major axis. Okay, and then your LZ here, the length of the column is 5,000 minus with 500. 500 is the, tengok apa? Okay, 500 here, okay, is the H of the main beam. Okay, for LY, okay, effective length for the Y direction is equal to 5,000 minus H of the secondary beam here 400. So you will get your effective, your clear height here. And then beam, for the main beam, you just write down because the value is there. Okay, so tak ada masalah. And then you calculate the moment of inertia BH cube over 12. Okay, for the column, you have to remember, okay, for Z axis, which is BH cube over 12, for Y axis is HB cube over 12. Okay, and then the unit is millimeter power of 4. Okay, and then you do the same process for your beam. Next is for the stiffness. Okay, for the stiffness, K is equal to EI over L. So K, I is from the IZZ, and then here is from IYY for the column. Okay, unit is mm power of 4. Okay, and then for the beam here, K for the main beam, you ambil I main beam 1, and then here I main beam 2. Here I secondary beam 1, I secondary beam 2 divided by length of the beam here. So length of the main beam 1, length of the main beam 2, length of the secondary beam 1, length of the secondary beam 2. Okay, and then relative column stiffness here. Okay, the relative column stiffness here is equal to K column divided by 2 times with the summation of K beam. Okay, so the value here should be more than 0.1. So normally both value is the same. Then you have to repeat for the Y axis, the value should be less than 0.1 or equal lah. Okay, so if you get more, you use 0.1. And then here we consider as a brace column. So we have to calculate the effective length of the column by using this formula. Okay, by using this formula, L0 is equal to 0.5L times with 1 plus K1 over 0.45 plus K1, 1 plus K2 over 0.5 plus K2 square root. Okay, so you have to calculate both axes, LOZ and also LOY, effective length for the Z and effective length for the Y. Okay, and then your LZ and also LY, you take it from here. Okay, from here. Your LZ and also your LY from here. And then the K1 is a value is from the previous one. Okay, for the Z axis, you take the Z axis, of Y axis, you ambil yang Y axis, you will get the effective length. Okay, you have to remember this formula, but it is open book test, so you don't worry about that. So you will have your own reference. Okay, radius of gyration is I over A, square root of I over A. So I is actually I small, IZ is equal to IZZ. Okay, from radius of the IZZ here, 0.98. Okay, from the column. Okay, IZZ for the column. Okay, and then IYY for the column. Okay, and then you divide it by A. Area is A is the area of the column. Okay, area of the column is 27 from this one 275 times 350 millimeter. Okay, and then slenderness ratio is equal to L0 over I. So you have to calculate slenderness ratio for both, which is for the Z axis and also Y axis. So 2795 over 101. So you take this value and then you will get the ratio here for both axes. And then last but not least, you have to calculate the slenderness ratio, slenderness limit for both axes. So the formula is 20 times A times B times C over square root N. So as I said that A is equal to 0.7, B equal to 1.1, C is equal to 1.7 minus Rm, because this is biaxial bending. So therefore, you have to calculate Rm for both axes. Okay, you will have Cz and also Cy here. So you remember I told you before here, you have to put in the negative value here. Okay. And then you calculate your N is equal to NED over ACFCD. So your N, don't forget your NED times 10 power of 3. Okay. And then you will get the answer for the lambda limit Z and also lambda limit Y. So you compare with your lambda Z and also lambda Y. So in our case here, the lambda Z is less than lambda limit Z, lambda Y is less than lambda limit Y. Therefore, the both axis is considered as a short column or non-slender column. Okay, this is just a simplified method in order for you to calculate the effective length of the column. You may study it by yourself, okay? Because normally we didn't use it, but if you would like to use it in your exercise or in your exam, I will accept it. Okay, so no, I will have no problem for you to use this method because it's already here. Okay, I think that's it. Okay, for the column classification. So I don't have any things that would like to continue. So if you have any question, I will open for question and answer session. Ada soalan nak? Oh, on the book itself, I will try to get the soft copy. So if I do have a soft copy, I will pass to you as soon as possible. Any other question?
Sir,
Yes.
yang untuk yang assignment tu, apa yang submission declaration form tu macam mana, sir?
Okay, on the submission declaration form tu ada dekat Google Classroom. So Dr. Wood already upload it over there. So you may download it from there ataupun you boleh isi dekat sana. Okay. So if you didn't get it, let me know.
Okay, sir.
Okay, any other things? Okay, if there is no other question, okay, that is end of our class. So for the next class, so we'll continue on the example for the column design, reinforced concrete column design. So we will go through on the uniaxial first, either it is short or slender. So I will told you later. Okay, that's it for our class. Don't forget to fill up your forms, okay, for attendance form. So thank you. Assalamualaikum and a very good day.
Waalaikumsalam. Thank you, sir. Selamat buka saya.
Thank you, sir.
Okay.